going to walk through this Extrema problem by this step-by-step method. So here's the problem over here. Y equals x square root 4x minus x squared. So our first issue here is to find the domain of the function. So let's start doing that. So if I want to find the domain, I need to look at, are there any denominators? Are there any radical signs with the even index? Are there any logarithms? So all that I see right here is I see a radical sign with an even index. So I know that the radicand has to be greater than or equal to 0. So I'll just go 4 minus x squared greater than or equal to 0. X squared greater than or equal to negative 4. Sorry, negative x squared. I can multiply both sides by negative 1, and I get x squared less than or equal to 4. So I just had to flip the inequality sign, and I happen to know that the answer to this is negative 2 to 2. Because once x gets above 2 or below negative 2, this will not be true. But if you're not really familiar with that, there's a way to solve this. So when I have an inequality where my value of x is greater than a linear inequality, so it's a power of 2 or higher, I have to solve it as if it's a polynomial inequality. And the way you do that is you get everything onto one side of the equation, or the inequality. So it's x squared minus 4 is less than or equal to 0. Now, I start to solve this by saying, well, what is it when x squared minus 4 is equal to 0? And I know that x squared minus 4 is x plus 2, x minus 2. So I know that it is going to be equal to 0 at negative 2 and at positive 2. And so what I'm going to do is I'm going to draw a number line. Here's 0, 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. Let's call that negative 5. Call that positive 5. And I know that I'm going to have a 0 right here at negative 2 and right here at positive 2. And what that does is it divides my number line here into 3 intervals. Because the only place that I can possibly change from being greater than 0 to less than 0 is at a 0. If I'm writing along in the function here, the only place it can possibly change is when I hit a 0. So once I do that, now all I need to do is test my inequality in each of these 3 intervals. So here's my inequality, and I'm going to start, let's write it, I'm going to rewrite it. I'm going to say x squared minus 4 less than or equal to 0. And I need to test it, first of all, in this interval, then I'll test it in this interval, and then I'll test it in that interval. Because all numbers in each of these intervals will be the same, whether it's true or false. So let's start out here and say, well, let's try, if this is negative 2, and that's positive 2, let's test negative 3. So if I'm testing negative 3, I would go negative 3 squared minus 4. Is that less than 0? No, it's not. This is 9 minus 4. That's greater than 0. So right here, the domain is false. How about if I try 0, which is right here in the middle, in the second interval. So I go 0 squared minus 4. Is that less than or equal to 0? Yes, it is. Negative 4 is less than 0. So in this interval, it's true. And now let's try a number in the last interval. Let's just try, let's pick 1. Okay? So is 1 squared minus, 1 is not in the, I'm in the wrong interval there. let's pick, that's 3. Also, 3 is going to give me the same answer. I have 3 squared minus 4 less than or equal to 0. 9 minus 4. No, it is false there. So my domain for this particular problem, as I said a minute ago, is -2 to +2. Let's go back and write that here in our answer. So the domain is -2 to 2. Inclusive. Inclusive is fine. Now I need to find what is the derivative of the function. So here's my function, and first I'm going to rewrite it. Y is equal to x times 4 minus x squared to the 1/2 power. And I realize that I have a product here. So if I have a product, I need to use the product rule, uv plus uv prime prime. And so I'm going to start working on this derivative. Well, the derivative of x is 1, so that's 1 times v, which is 4 minus x squared to the 1/2, plus u, which is x, times v prime. Well, this whole thing here is my v, this is my u. So v prime is 1/2 4 minus x squared to the -1/2, that's the outside, times the derivative of the inside, which would be -2x. So let's simplify that a little bit. Y prime is equal to 4 minus x squared to the 1/2 plus, well, I have this 1/2 and this -2. So actually, it's telling me I'm going to have the 1/2 and the 2 are going to go away, but it's going to make this a minus sign. And I have x times x, so that's going to be x squared. So it's x squared times 4 minus x squared to the -1/2. I would probably be okay if you left it like that, but with a little bit of experience, I can see here I can make it a little bit more simple if I factor out a 4 minus x squared to the -1/2. So I'm going to go 4 minus x squared to the -1/2. And that's going to be times, well, if this term right here is to the +1/2, that's just going to be 4 minus x squared minus, well, I took out the 4 minus x squared to the -1/2, so this is going to be just times minus x squared. Well, now I can simplify it even a little bit more, and I can say that this is equal to 4 minus x squared to the -1/2, and I'll get rid of that negative exponent in a minute, times 4 minus 2x squared. Because I have 1x squared and I'm subtracting another one, that makes 2x squared. So just to make it really simple right now, my y prime is equal to 4 minus 2x squared divided by, I'll use a square root sign here, 4 minus x squared. That's taking this term right here and now putting that into the denominator. So there I've gone back to our page and I've added our derivative now. So this is answering part B. Now part C says, what is the domain of the derivative? Well, let's go back and take a look at our derivative. So what I see in my derivative is that I have both a denominator and I have a radical sign with an even index. So let's first look at the denominator. The denominator is the square root of 4 minus x squared, and that cannot be equal to 0. So how do I find that out? I'm going to square both sides. I try to. Yeah, I got it to work. I'm going to square both sides. So I have 4 minus x squared cannot be equal to 0, because 0 squared is 0. I have negative x squared cannot be equal to negative 4, which is the same thing as x squared cannot be equal to 4. I multiply both sides by negative 1. So I get x cannot be equal to plus or minus the square root of 4, which is plus or minus 2. So x cannot be equal to positive 2 or negative 2. I'll put that in a little box right there. Now, the second part of my domain is that, well, I have the radical sign. I did the denominator. I have the radical sign right here with an even index. Well, I just did that one a minute ago, and it turned out that that domain was negative 2 to 2. So looking at this right here and this right here, I can see that my domain really is negative 2 to 2, but not including negative 2 or 2. That is going to be the domain of the derivative. So we'll write that in. The domain of the derivative is going to be parentheses negative 2 and 2. So part D says, list the x values of all critical points and endpoints. All right, well, let's go do that. So I need to find my critical points and endpoints. Here's my derivative, and I know the critical points are where the derivative equals 0 or where it does not exist. So if I want to find out where it equals 0, I take the numerator and I set it equal to 0. So 4 minus 2x squared equals 0, because anything divided into 0 is going to be 0. So I have negative 2x squared is equal to negative 4. I divide both sides by negative 2. I get negative 2. That goes away. I get x squared is equal to 2. So I get x is equal to plus or minus the square root of 2. That is where my derivative is equal to 0. Those are critical points. So I'm going to go put those back into my, now here I haven't started listing it, so I know one critical point has an x value of radical 2, and I know that another critical point is negative radical 2. Those are both critical, and those are where the derivative equals 0, so those are also both stationary. I'll put a y. Let's put y since that's what I'm asking for. Yes, yes, those are both stationary. Now, I also have a couple of points where the derivative does not exist, and those were at negative 2 and positive 2, because if you remember, the domain of my derivative looks like that. It does not include negative 2 and positive 2, but the domain of my function does include negative 2 and positive 2. So those are clearly endpoints. The derivative doesn't exist because they are endpoints. So if I was drawing a little function, I don't know what this particular function looks like. You remember that a derivative has to, this point right here would have a derivative coming from the right, and this point here would have a derivative coming from the left, but in order to have a derivative, it has to have both a left and a right. So the endpoints can't have derivatives of both sides. So the derivative does not exist, but these are endpoints. So let's go back to my diagram here, and I can see that I have a point x value at 2 and an x value at negative 2. They are endpoints. Well, they're not stationary because the derivative does not equal 0, Are they critical points? I think they are critical points because a critical point is either where the derivative is 0 or does not exist. So I would say yes, those are also critical points. But they are also end points. So now I have to go back to my function and see what are the y values of all of those critical points. Well, the points were square root of 2, negative square root of 2, 2, and negative 2. And to find out what the y values are, well, I'm just going to plug them in here. So, excuse me, I have, this would equal radical 2 times the square root of 4 minus radical 2 squared. So that's going to be radical 2 times the square root of 4 minus 2. Well, that's radical 2 times radical 2, which is equal to 2. And that's going to be pretty much the same for negative radical 2, because the only thing that I'm changing, well, no, I take that back. It's going to be negative 2. So I would have negative radical 2 times the square root of 4 minus negative radical 2 squared is equal to negative radical 2 times the square root of 4 minus 2, which is equal to negative radical 2 times radical 2, which is equal to negative 2. So I found a couple of my y values. This is 2, and this is negative 2. Now I can try it with my endpoints here. Let's try it with 2. So I have equals 2 times the square root of 4 minus 2 squared. Well, that's equal to 2 times 0. So that's equal to 0. And I have a feeling the same thing is going to happen here. I would have negative 2 times the square root of 4 minus negative 2 squared. Well, that's negative 2 times 0, which is also equal to 0. So going back up here, I now have my other 2 points, 2, 0, and negative 2, 0. So I made myself a little graph here just so I can visualize what's going on here. So I have the point radical 2, 2. So radical 2 is about 1.4, and that's going to be at 2. And I have negative radical 2, negative 2, so I'm going to have a point right there. And then I'm going to have a point at 2, 0, and I'm going to have another point at negative 2, 0. Now remember, my domain of this function starts and ends, and starts at negative 2 and goes to positive 2. That's it. This is the whole function. And the only turning points that I possibly have are these critical points that are stationary. So I think this graph is going to look something like this. Now, just to kind of test myself, if I have the point x equals 0, what would that be in my function? Well, if x was equal to 0, then my function would also be 0. So I can also see that I do have this point 0, 0. And now I can see very clearly that my point radical 2, 2 is a max. And in fact, it is an absolute max. And my point negative radical 2, negative 2 is a min. And it is an absolute min. And I can also see that this right here, my point negative 2, 0, it is a maximum. But it is a relative maximum. It is a relative maximum, say, for example, in that neighborhood right there. And I can also see that my point, I gave it the wrong point. That was the point negative 2, 0. That's down here. That's the max. And my point over here Positive 2, 0 is a minimum. It's relative, it's not maximum. So by taking this very systematically, I think we were able to solve this problem for all of the extrema, all of these questions.